Good evening. Sorry we're starting a little bit late. I hope that more students can trickle in if they can make it across campus, grab a bite to eat, and then get into this lecture. So thank you for attending tonight's lecture. It has been my pleasure and the pleasure of the BSSD Sustainable Design Program to host Rick Collins for workshops and class visits and then this lecture over the past 2 days. I want to acknowledge everyone who worked hard to produce the events of the past 2 days, and it's really exciting to see most of the people who went to the solar mill demo yesterday are here. Thank you for coming. Many of the students in my class who participated in a barn raising this afternoon are here, and the people, Josh and Jay, who helped to do that work are here. Thank you very much for coming. And I want to really thank Rick Collins and Nick Collins for meeting with myself and Tali, the Sustainable Design Program Coordinator, over the past month and months to imagine how we could bring sustainable timber into the classroom, into a lecture space, and into more of our sustainable design program and college this fall. We hope this will be the beginning of multiple ways of connecting with sustainable timber and learning from them about circular economies. I want to thank Lowell Miller, the Architecture Program Fabrication Shop Coordinator, Quinn Connolly with Facilities and Services, and Justin Bozo with Illinois Extension. They did the work of securing the grant, developing the mill, and beginning this fledgling circular economy on our campus where we can reuse locally sourced timber for various projects. And then the Firmitas team, Josh is here, and all who helped prepare materials for the barn raising this afternoon in the FAA 230 Sustainable Design of the Built Environment course. I thanked Tali, but thank you for coordinating all of the incredibly complex parts of this opportunity. And very importantly, the student organizations that help make this possible. These events were co-funded by a grant from the Student Sustainability Committee and the Sustainable Design Visitors Program funds. We also are co-sponsored, but not co-funded, by TREE, the Epsilon Eta Epsilon professional sustainability fraternity, and Root to Roof, who are working on sustainable timber and construction. I also want to thank Eric Green from the Institute for Sustainability, Energy, and Environment for connecting Rick and Firmitas with us last year and facilitating this workshop access across the College of ACES and throughout the community. So I'll start today with the land acknowledgement and then quickly give you Rick's bio and then let him have the stage. So we'd like to begin by recognizing and acknowledging that today we are gathered on the lands of the Peoria, Kaskaskia, Piankashaw, Wea, Miami, Mascoutin, Orawa, Sauk, Meskwaki, Kickapoo, Potawatomi, Ojibwe, and Chickasaw nations. The lands we occupy as an institution were the traditional territory of these Native nations. This university has also possessed and sold to private individuals lands previously held by Native nations in other areas of North America now called Nebraska, Minnesota, and Oregon. Thus, the list of Native nations displaced includes many more than those already named. All these lands continue to carry the stories of these nations and their struggle for survival. As a land-grant institution, the University of Illinois has a particular responsibility to acknowledge the histories of dispossession that have allowed for the growth of this institution for the past 150 years. We are also obligated to reflect on and actively address these histories and the role that this university has played in shaping them. This acknowledgement and the centering of Native peoples are essential acts of this institution as we move forward and into the next 150 years. So it's my pleasure to introduce Rick. Rick Collins is recognized for his expertise in the history and future of timber frame building. His portfolio encompasses visionary buildings that redefine the role of wood in the built environment, as well as authentic restoration and preservation work. A structural timber expert committed to the preservation and continuation of our built and natural heritage, Rick is a master carpenter with formative experience in metalwork and mechanics, and one of only 20 people in North America to carry the certification of Journey Worker Timber Framer. He holds a Bachelor of Science in Forest Science from the University of Illinois Urbana-Champaign and served in the United States Marine Corps Reserve as a combat engineer. A self-taught scholar in the methods and tooling used by Europeans who settled the Midwest from the 1600s to 1800s, Rick has long cultivated creative energies within the U.S. timber framing trade. Today, he focuses his energy as a consultant and subject matter expert, enhancing project efficiency and contextual relevance by grounding process with practicality and linking community with place. So I will give it over to Rick to present to you.
Thank you. This presentation, utilizing timber in the Midwest for building, is something that Nicole and I started working on a couple of years ago. And we gave a trial version of this at Iowa State University in Ames, I think 2 years ago. And Nicole has put a substantial amount of time into preparing this presentation over the last couple of weeks. And I certainly couldn't do this without her collaboration. You know, my training and my background is a bit atypical in terms of carpentry. I did get an undergrad here at this university. I did spend some time in the Marine Corps Reserve. And I spent a solid decade pretty intensely studying timber frame technology, which took me mostly to Europe and around the United States and a little bit to Canada. And in general, with these particular professions, it's a solid decade of training to get to the point that you reach some level of high proficiency with timber frame technology. And so it's not really typical of what we consider carpenter training in the United States today, which is done in a couple of months sometimes, or in some cases. And over the last 10 or 15 years, I've been doing this now for 30 years. So the last 10 or 15 years has been a little different. And our economy, of course, has been different. And we had COVID for a few years and all these kind of things. So it did end up shaping our business a little bit. And so now Nicole and I collaborate pretty extensively on presentations. And we feel that a big part of our work is outreach and education. And so we want to take what we've learned over the last several decades and we want to teach people about it. And part of the reason that we want to do this is because we really, really believe in what it is that we do. We really believe that you can actually utilize timber in the Midwest. So I'm going to talk about that today. And I'm going to talk a little bit first about what's been unsustainable and the practices in Illinois. And I'm going to talk about Illinois mostly tonight. And when we talk about Illinois, we can talk about Iowa too. We can talk a little bit about northern Missouri. We can talk a little bit about, it's hard to talk about Indiana. But Illinois and Iowa and southern Wisconsin share a lot of traits. And when we cross the Wabash, things change a little bit. So we can talk about that part of it. But what I'm going to focus on in terms of utilizing timber is really about Illinois and Iowa and southern Wisconsin being south of the Wisconsin River, and really north of Garden of the Gods, north of the southern tip of Illinois. So most of my timber experience is in that zone. But we're going to talk a little bit about what's unsustainable. And what has been unsustainable? Well, there's been zero harvesting practice. That's what we would consider acceptable. The entire state of Illinois was clear-cut in 1860. And the entire state of Missouri was clear-cut in 1890 to 1900. So this entire landscape that we live in has been subject to, almost zero protections in terms of forestry. There's been almost no replanting initiative. Iowa is ahead of the game in terms of this in regard to Illinois, so is Wisconsin. But in Illinois, there's been almost zero replanting initiative. Replanting has come down to and again, I'm talking about hardwoods, so we're talking about north of Garden of the Gods, for example. But replanting has really come down to the landowner. It hasn't been something that the state has gotten involved in. And there's been permanent ecosystem degradation, and that has been considerably unsustainable. There have been, of course, many invasives which are jeopardizing our woodlands. And early on, at least until the 1970s, land was sequestered for grain and animal production. By animal production, I mean grazing of woodlots, which shouldn't happen in this area that I'm talking about. You should not have animals in the forest. You can put animals in there for a very short period of time, but essentially what happened from 1860 on was that all the trees were cut down and people grazed hogs and cows. And our forest, for example, where we live, not a single oak tree germinated from about 1865 until we got a hold of the property in 2000 and pulled the cows off of it. So very, very unsustainable practices in Illinois. We've also been producing very low-value industrial material with short lifespans, and by that we're talking about all the hardwoods in the Midwest and the Mississippi River Valley that are shipped to Alaska for crane mats. Low value-added products like firewood, which has a very low value add. And the stave and the veneer markets have sucked up much of our timber, and this is the global market. A lot of it goes overseas. Of course, a lot of it gets used in Ohio. The French really like Midwestern oak from the Ohio River Valley. And then, of course, we've simply just left whatever we don't want in the woods, which hasn't worked out so well for us. We don't utilize the byproduct of harvesting. And, you know, this entire region practiced slash and burn technology, which we criticize folks in South America for now. But it was what was done to this state and to all of the Midwest. All the trees were cut down, all the land was burned, and it was converted to agriculture. And by all, I'm really saying like 99% of the land area. And then there are unwise development choices, overdevelopment, sprawling development, building things that have such a short lifespan. So we live in what I would consider a very unsustainable world right now in terms of Illinois. But what is sustainability? And these are basic principles, I think, that everybody who is conscious of this stuff is aware of. But establishing forest management plans that are enforceable, controls governing harvesting. Right now in this state, if you own a tree, you have the right to cut it down. In other parts of the world, you can't do that. You have to get a plan, you have to get permissions, and right now it's okay for you to go out and cut down a 350 fully live bur oak in your yard that will live another 150 years because it might be encroaching on your garage, or you don't like the noisy acorns. That is something that we need to change, and we need to do robust replanting. Coordinating the invasives management a little bit so that we understand some of the problems that we're having with invasives. And then ecosystem considerations and improvement of our ecosystems. Closing the loop on wastes, which, as I said, in general, when you harvest hardwoods in this state, in this area that I'm talking about, Iowa, southern Wisconsin, and the northern 2/3 of Illinois, everything is left in the woods in general. And if it's not left in the woods, it's just cleared out for firewood. And then I think this is the part that spurred my interest 30 years ago, creating like impactful regional value-added products. So thanks to Dick Brzee, who's in the audience, I learned a little bit about forest economics, and I started to learn a little bit about what value add meant. And I started to understand that if we were gonna make change, that we had to increase the value add of what we're doing. And so I started to think about, you know, there are things we can do with wood. You can build a violin with wood that's worth $40,000, that's 5 board feet. Okay, that's a little bit extreme for the example I'm giving, but in the world that I started to think about building timber frame buildings again, because, and I'll talk about this a little later in my presentation, but you know, I started to think about this idea that we should build things that would outlast the trees that produce them, or at least the economic maturity point of those trees. And create substantial things, not cutting boards, not birdhouses, not countertops, not small volumes of wood, but substantial products with long, long life cycles. So this intro that I'm giving is going to explain a little bit about it. I think what it'll do is it'll identify a little bit about the rest of the presentation. And I have 89 slides to go. So I'm going to speed up a little bit. But it's going to be a lot of pictures. But I wanted to spend a little time on the front end talking about and really calling out the fact that we're not doing a good job. We're not. We're not taking care of our landscape. We're not taking care of the state. And we need to change that. So what can we do? And what have we thought about doing? One of the things that we need to do is we need to bring back and change the vocational programs. Multidisciplinary discourse and training, and that's what we're doing right here. I'm a practitioner of this for decades, and I'm coming to a university to create this discourse, this multidisciplinary training. I do these things called lunch and learns for architect and engineering offices, where I try to go and teach what I know to architects and engineers and exchange information. And we need to invest in our wood sciences research again. We just presented at a conference in Croatia and visited their forest products lab there, and it's refreshing to see an investment in a substantially small country that is really taking its resources, trying to take its resources seriously. Of course, we need government, industry, and support and initiatives. We need to change the codes. In the 1930s, the steel concrete industry got together and lobbied against the wood industry and changed the codes in favor of steel and concrete and eliminated a lot of things in wood. And we are still fighting those changes from 90 to 100 years ago now when we go to build wood buildings. They are unreasonable changes that were made in the 30s. And we need cohesive policy change, things that people can understand and that make sense and are connected. Public education is the one part of this that we felt we could do, that we could educate the public about what we've seen. And instilling a value of the hand trades. As I said, for what I'm doing, it's a solid decade of training before you can really be unleashed out into the workplace to do the kind of work that I'm talking about and will be talking about. And there's a value to that, and we need to bring that value back. And this area has not, in my opinion, valued this since the mid-19th century. So what we see in places where wood sciences work is this cooperation and this value for hand trades. Also, understanding the sophistication of traditional methods. We have to remember that the work that I'm talking about, and we'll talk about tonight, has been going on for a solid 3,000 to 4,000 years, since the beginning of the Iron Age. It hasn't changed. It hasn't changed. And it didn't change until the last 50 years. So the work that we do comes from a very, very sophisticated background. And understanding that and acknowledging that sophistication is very important, which ties in with respecting past technologies. So what do we do? Our company does a lot of restoration and historic preservation. And my work over the last 30 years has shifted from, a technician essentially, or a practitioner in the field, which I still enjoy that kind of work, to doing many things, going from basic carpentry to very advanced carpentry, and now to trying to collaborate and consult with people and educate. But we do all these things. New construction, we lift and move a lot of buildings. I'm passionate about saving buildings, either in situ or moving them by dismantling them or entirely. I just don't want to see things torn down. And it takes a lot of work to build a timber frame, hundreds and hundreds of hours. It's 3 person hours per joint every time you see a timber frame. That's a lot of time and it's a lot of investment. So we move and save a lot of buildings, and we also do architectural sculpture, which I think is valuable stuff. And I think, one of the boons of recent technologies is it's really increased our ability to communicate our craft to other people. Whether it's been through computers, whether it's been through scanning, which I'll get into a little bit, whether it's simply email, the kinds of CAD programs that are available now. There's half a dozen that are very useful. Early on, we started off with German software programs, and then finally, about 10, 12 years ago, AutoCAD got on board and we switched to AutoCAD. But so much software has changed how we communicate, especially with drafting, design, and engineering. In our collaboration, early on, we were doing a lot of very basic education about things, and we were trying to bring awareness to the community at large. We were trying to educate the professionals we work with, architects and engineers mostly. Most folks in those fields have a strong concrete and steel background, and that's the focus of the training, and a very low wood background. You know, earlier in time, not so long ago, if you were going to be an architect or an engineer, you had to spend a minimum of 5 years working in the field in a trade before you could consider that, and then you might be an architect or an engineer, and then you might be a master builder after that. So part of what we have to do is educate a very large pool of people that have very little wood training in this country. And that's something that we take very seriously. We also need to educate and inform stakeholders and government entities. And our industry is trying to guide code changes. We're trying to make changes to the code. We have an engineering council as part of our organization, and we have been trying to guide code changes to reverse these things that were done in the 30s. So that's the end of my extended intro. So now I'm going to speed up. This is a tower we built in Danville at Lake Mingo. Has anybody been there? Lake Mingo? You two have been there. You've been there. Anybody else been to Lake Mingo? Serious? Okay, this is only 30 miles away. I built this out of 40-foot long bur oak logs that were they finished at 14-inch diameter octagons, and we did this in 2003. This is one of our shops. This is an armory in Galesburg, and we have several shops. But this one's in town, and it's a building that we saved, most likely from demolition. This is what an Illinois woodland often will look like. These trees are all post-Civil War, so when they cut down all the oak trees in Illinois during the Civil War to build railroads, they sprouted back, and then they ran cattle and hogs in there, and then oak trees didn't germinate again for another 150 years. So this is an even-age stand of white oak that is on our property, and it's been high-graded at some point, which means the nice tall straight ones were pulled out and the leaners were left. Big part of our work is teaching people how to use leaners and bent pieces for the work that we do. So where are we? The little star is Champaign-Urbana, as you may know. The big star is Galesburg. That's where our shop and our farm is. The region that we work on a daily basis is in this circle right here. And of course, then we work nationwide. We also work in the Caribbean. We go overseas. But the bulk of our work, our day-to-day focus is within this circle. And my personal focus is really, as I said, more Illinois, Iowa. So what is timber framing? Well, this is how it starts out. This is your typical Illinois, Iowa, Indiana, Ohio even, white oak log, and they tend to be, right now, harvesting, in our area of Western Illinois, they're cutting down trees from about 150 to 180 years of age. It'll be another 150 years before we have trees to cut down, if they regrow, because nobody did any replanting in the interim. And peeled, this is what white oak logs look like. We did a big job with a visitor center in downtown Memphis, and so threw this slide in here just to give you an idea of your sort of typical size and what that log looks like. And then the finished product, exposed floor joists and ceilings, for example, exposed timber. This happens to be rough sawn pine. And glue lamps are something that we also do. This is Port Orford cedar. These were about 90 feet long. And so we sort of embrace all parts of the industry. We're not totally married. I have personal opinions about some of these things, but we also live in the real world, and we work with all these products. CLT is another one. CLTs are not new. CLTs go back to really the late 19th century. And years ago, 2007, I took down the beef barn, which used to be out here on the South Campus, and it was supposed to be relocated as a museum in Piatt County. And the people panicked and ran out of money, and they didn't end up putting it back up. But the floors in that 1910 beef barn were just like this. So this is a technology that's very old. The difference is that today we're doing it with glue, and in 1910 they were doing it with nails. And this is how we use CLT today. It's primarily used for floor systems, although we were involved in the Abbott Theatre in London, which was kind of an interesting project a little bit, and it is a complete 8,000 seat auditorium where ceilings, walls, HVAC channels, everything, the whole thing is CLT. We've fabricated a few CLTs. This one we did for Notre Dame University, and it has poplar core with Doug fir. So it's possible to build CLTs and NLTs on a small scale. So traditional work is where my passion really began, and it's structural framework using large timber. The earliest examples go back really about 4,000 years, and the thing to understand about 4,000 years ago is that the joinery that they were using, which are the mortise and tenon connections, are the same size as the joinery we use today. The tenons 4,000 years ago were 1.5 inches. The posts were 8 by 8. The pegs were 1 inch. We've been doing the same thing for 4,000 years. So it kind of goes back to that time frame. There are earlier examples of wood being used in wells and things like that that go back further than that, and some boat building stuff, but the oldest timber frame found is 4,000 years old. Timber framing today looks a lot like this. This is what a new house might look like that we would build, a cross-gable building with standard Doug fir, knotty pine ceiling. This is classic timber frame home magazine timber frame. So we've participated in this market. Years ago, I presented in Russia, and this is the Church of the Transfiguration on Kija Island. And so it's not just timber framing, there's a log building component to this that goes hand in hand. This is the largest, I think it might be the largest log building in the world. It's certainly, I think, the largest log church in the world. So there's a little doorway over here. You just can't get sense of scale here. It's absolutely enormous. But I presented at this building museum in Russia and had an opportunity to tour that. And of course, the English have been doing hammer beams for a very long time. These are about 1,000 years old. Hammer beams were probably invented around 1,000 to 1,100. So hammer beams are the highest art form in terms of timber frame roof systems. And they're 1,000 years old. We struggle sometimes doing very, very simple things now with our carpenters. And French, this happens to be a French building, again, from about 12 or 1,300. And you can see the redundancy in these really early timbers. They're very large, a lot of elm and ash and white oak over the time period from about 1,100 to 1,500. But the highest form of, some of the higher forms of timber framing really were about 600 or 700 years ago. And sometimes you don't even know it's a timber frame style. I think in the 17th century or so, if I remember right, the French controlled the central part of Italy for a while, and they enforced the first seismic code. And so this is actually a timber frame building with a brick veneer and infilled from the mid-1600s, infilled with stone, diagonally lathed on the inside and plastered. So this part of Italy was the first place to get a European seismic code about 400 years ago, and they chose to use timber frame, which is the best seismic material. And on a recent visit, we were speaking at Zagreb University in Croatia just a few weeks ago, and we ran across this fachwerk-style German building from the late 1800s, built by some Austrians. And these are buildings that are all around us here in the Midwest, except for the upper right. That's a replica of a church I built in Richmond, Virginia, 1609 church. But the rest of these are mostly Midwestern. And this is Iowa and Wisconsin and Illinois, and that's Oklahoma. Well, that's Pennsylvania, so that's in the east, I guess. But these kind of buildings are all around us all the time, and they're timber frame buildings. Illinois had 500,000 timber frames in 1900. There's certainly less than 100,000 left now. We've lost so much of our building inventory for what I would say is no good reason. Too many buildings have come down, and it's partly because of a lack of understanding. It's partly because of a whole lot of other factors. More buildings in Illinois. Upper left is a barn we restored, for example, in Naperville Far right is the largest wooden fort in the United States that I built 25 years ago in Paducah, Kentucky, Metropolis, Illinois. This is a barn we built in Chicago for first wooden building to be built since the Great Chicago Fire in the city of Chicago. And it's a timber frame at an organic farm. Grow Mill in Chicago, and a classic sort of timber frame structure we built for Notre Dame University. This is all right here in the Midwest. So what exactly is timber frame? At its basic level, it's mortise and tenon joinery. And it's not just wood to wood. The precedent for using iron or bronze or metals goes back thousands and thousands of years. And in fact, the oldest truss known in Europe and North Africa is in Tunisia, and it's from the 6th century. And it is what's called a Roman truss, and it has an iron bracket that holds the king post to the tie beam. This is a very, very typical Midwestern barn. This is called canted queen post, and hundreds and hundreds and hundreds of thousands of these, 500,000 of these are built in Illinois and Iowa in the late 19th century. Easily 500,000 of these buildings. There's a fraction of these left now. They are built in such a way that they should have lasted hundreds and hundreds of years. But they can be taken apart, and they can be moved, and that's the beauty of timber framing, that you can have a building that no longer has a purpose in one place, and you can take it apart and put it up somewhere else, not make it into flooring, not resaw it into other little bits and pieces, but use it as a building. Again, engineered timber is another part of this industry. So our timber framing evolved into work like this that involves CLT, mass timber, and glulam, but the foundations of what all this is this traditional work. And so part of why we talk so much about traditional work is because we believe that to do this, first you have to understand where it came from, and you have to be proficient at that before you can move to this kind of work. This is in Glencoe, Illinois, and it's a theater facade that we built in 2015 out of Port Orford cedar. These are all tension members, so they're carrying that lower cord, which is 55 feet on this side and 90 feet going that way. This is the first CLT building in Chicago that we built. This is down by Shedd Aquarium. And it was exploring how far you could cantilever CLTs without them deflecting. And the experiment proved that CLTs deflect. So we had to put on a giant fascia to hide the 4 inches of sagging in that roof system. So unsupported CLTs aren't really all that great. Bridges, these are more modern bridges. We built a series of bridges in Tulsa, Oklahoma, using nail laminated and post-tension technology, which these kind of bridges rival. This kind of bridge you can have 2 passing fire trucks on. So it's rated for that kind of thing, and it will outlast a concrete bridge. This is this project you've seen before in these slides, but this is Notre Dame University's CLT wall, and a stave-style building that we built in Memphis out of Illinois white oak logs. These are 14-foot tall peeled oak logs stood up on a foundation in this stave style of technology. Milwaukee has the largest CLT building in the Midwest. Only this front corner of it is CLT. And of course, big wood has been planned in Chicago, or not planned, but talked about in the South Loop for over a decade now. So these things are, this use of wood, utilization of wood, I believe that all wood should be utilized, good, bad, poor, and whatever it is. Make CLTs out of it, make timber frames out of it, do whatever we can. But where does it come from and how do we make it? So for us in Illinois and Iowa, it starts here. And just in general, when folks harvest hardwoods in this state, you can do there is selective harvesting, but there's very, very, very little replanting. And the harvesting process for our Midwestern hardwood starts like this and ends up with pieces on the ground. And the beauty of timber framing is that we can use what we call live pieces. So this white oak log, which is about 170 years old, has a really big sweep in it. And with timber framing, you can use that sweep. In England, they build frames since the 11th century called cruck frames, which have this natural sweep built into those logs. So you can take something like this out and utilize it whole, or you can chop it up into stuff that's straight. And chopping it up into stuff that's straight leaves a whole bunch of biomass in the forest that we don't currently have a use for except to make firewood out of. But this is what a typical Illinois white oak log pile looks like today. Like I said, we're not going to see this for much longer because nobody was replanting since 1860 in any meaningful way in this entire state north of Garden of the Gods. So we've got a bit of a challenge ahead of us. And in terms of technology, we're starting to see some things like this that are absolutely fantastic. We've incorporated a scanner in our work now for about 4 or 5 years. We find it incredibly useful in dealing with old buildings. Now I scan almost every single old building that we look at because it's a fantastic way to record data. We can also do this in the woods, which allows us to do selective harvesting. We can do whole tree utilization this way in a better way because I don't have to keep all this in my head or draft it. We can plot where these things are in a very easy way so that when we do a project, we can find the timber that we need and we can create something that's very highly value added. So in the north side of this picture, the top of it, the dark green, is what you call natural forest. Everything down there is plantation. This happens to be from the UK. But it's one way that we can start thinking about our forests in the non-industrial private forest sector, which is what we are all living in right here. This is all non-industrial private forest. And if we want to utilize things in the woods that have extreme value, but we can't find them or see them, this is one really good way to do that. You can also calculate basal area, which is the standard for foresters, calculating how much biomass, how much volume of material is in the woods. You'll notice in this picture, it doesn't look like an Illinois forest because it's not full of honeysuckle and Russian olive. So it's a little bit harder for us to employ this technology in a place where we've got such massive undergrowth problems. And forests like that tend to create machines like this, which are feller bunchers, which is not really something that we see in a small scale. But I'm going to talk a little bit about conversion methods, where they start and where they end. And they start like this with hewing. I've done a lot of hewing. I've done a lot of hand conversion of logs to square material. This happens to be at a conference Nicole and I attended in Limoges. But this is how you do it. You line up a bunch of people with axes and you square the material. Downside to hewing is that if you have really nice logs, you're wasting a whole bunch of wood. If you have crappy logs like these, then you can really utilize something that would otherwise be thrown away because you can hew off the faces you don't want. And years and years ago now, we started to do some slabbing. This is a 275-year-old bur oak log that somebody took down because it was too close to their garage. It was perfectly healthy. But this is very, very simple technology with a chainsaw and of course the Lucas mill is also very, very simple technology, but it's effective and it allows you to deal with some fairly large pieces. Over the last 30 years, I've had 7 wood misers. This is one of them, probably from about 15 years ago. It's an LT50 with a pretty large bur oak log on it, probably about a 7,000-pound bur oak log. And so this is the next step up. This is an LT70. This was another one of our mills at one point in time with an edger behind it. So this is kind of the small sawmill. This is what we're talking about when we talk about the Midwest. This is the level we're at. We're here or a little bit below. And then the bigger mills, this is East Perry Lumber Mill in Missouri. They're still run, by somebody at a control board, but the human is not really looking at the timber so much anymore. We're just cranking it out faster. And then at a very large scale, automated operations like this in Oregon. In terms of fabrication, we have similar choices. We can stay with hand conversion, or we can do CNC fabrication. I personally like all of it. I think it all has a place. So this top photo is a CNC machine. It happens to be a Hundiger. And then, of course, you can do all this work by hand as well. There's varying places in between that. This is Michael Young, our lead draftsman. He's been with us 8 years now. And this is just kind of a typical shop scene. This is cleaning up a mortise. This is also a typical shop scene, running a mortiser to punch mortises. This is kind of the level that we're at here in the Midwest. We're not really at the Hundiger level. We're more at this level, and this is the level that I've been operating at for a very long time. And then the Hundigger, which is this machine, allows you to feed the timber in. You create a drawing in AutoCAD, you convert it to machine code, and it cranks out the frame. Totally applicable. If you need 500 rafters that are all the same, it's perfect. If you're going to build 7 bridges that are all the same, it's perfect. There are a lot of things you can do with handwork you can't do with the Hundigger. There are a lot of things with the Hundigger that are a heck of a lot faster than doing them by hand. It's simply, it's got this kind of, 40 to 50-inch circular saw blade, power feed, control stops, these kinds of things. Totally a useful machine, but not the only machine that we should be using. So what are the real benefits of joinery? I think there's seismic, wind, fire. I think it's life safety. Timber frame buildings are stronger, last longer, and are more resistant to wind and seismic activity in terms of life safety than concrete is. And so we're seeing a big movement in the Mediterranean to shift from concrete structures to wood structures again, or to masonry infilled structures. Wood has a burn rating of about 1 hour per inch. So if you need a higher burn rating, you can just use a little bit larger timber. The seismic part of it is really interesting. Nicole and I have been studying the French timber frames in St. Genevieve that survived the 5 magnitude 8 earthquakes of 1811 to 1812 that flattened every building almost from New Orleans to Dubuque, even farther north to Minneapolis. There weren't many buildings left standing, but St. Genevieve survived. So we started to study these buildings from the late 1600s and early 1700s that still exist, that are a blend of Native American technologies, we believe, with French timber framing. And they are fantastic structures, and they could serve us for another 300 or 400 years. There's just no doubt. Fantastic design. There's just almost nothing to improve on here. Just almost nothing. And then wind. So we threw this in here because we've been building out buildings in the Caribbean to try to replace concrete, because embodied energy and concrete and island economies and diesel fuel and all these things that are sort of bad about habitating deserted islands, desert islands. So we've started to build with wood, and our wood buildings are withstanding 170 mile per hour winds, which is fantastic. And we had to do some new sort of engineering modification. And so we've now started to create a whole line of timber frame buildings in the Caribbean that nobody else is doing. Not that they couldn't do it, just we've been a pioneer at this particular end of it for a while now. We've come up with different wall systems. We call it the hurricane wall, because not only there do you have to withstand the wind, you have to withstand the things that the wind is throwing around. So we've come up with a system that's primarily wood that is fabricated elsewhere and then shipped in and installed with very little waste. This is University of Iowa in Iowa City, and this is the 1832, what was the Capitol building, later the Old Main, burned. But look at what the timber frame does. Just 1.5 inches of char. They could knock those joints apart and take the pegs out. And there's some real question as to just whether or not that wood is probably still even sound after that kind of fire. Very, very fire resistant. And one of the more fascinating things we've worked on is just south of here. It's a great place to visit. It is the only building probably like it in the world, and it's in Shelbyville, Illinois, and it's a 148-foot clear span, 20-sided building built in 1913, all out of wood and steel. Probably, I have not seen anything like this anywhere else in the world. Which means that there can't be that many more. But it's absolutely fantastic. And it's right here in Illinois, and the roof was failing and collapsing, and the whole town half the town wanted to tear it down, and we were able to convince them to save it. And so when you look at this structure, we scan them, we do things like density testing of the wood, we create AutoCAD drawings, we do value engineering, and at the end of the day, this structure from 1913 met current code. We actually didn't have to make any improvements to this building, which is a rarity. It's a little bit of what it looks like from the inside. And currently we're working on this 20-sided building in Manhattan, Illinois. Again, there aren't that many of these in the world. There may be 100 in the whole country. There probably aren't that many 20-sided ones. But, you know, this had some serious foundation problems that if it hadn't had that, wouldn't have required the kind of drastic work that we needed to do. It did require a fair bit of upgrade for code compliance, but it's completely relevant, and it will be an event center. And because it's interesting, people want to save it. This is what our scans give us. This is the information it gives us. We can go in and scan a building and determine how out of level the floor is, which is what we've done here. We can raise and lower the floor to flatten it. We can scan the building and do value engineering analysis on the sides of the structure. This is what you can do with timber framing. This is not what you can do with conventional construction. You cannot go in and scan stick-built buildings this way. And you can't make the kinds of repairs to stick-built buildings that we can make to timber framing. So stop stick building. The sticks that you buy at the store are good for bracing. They're not good for building. I would just say we just all need to go back to building timber frames. There's just nothing else. It's the only solution. But this is the inside of Manhattan, and they are. In order for buildings to last a long time, you need to be able to fix them easily. Timber frames you can fix easily. And you can add to them. You can scarf joint onto them when the posts get rotten. You can, you know, the timber is big enough that you can actually work with it. You know, this is happens to be a girt from 1840. But it's renewable, it's replaceable. I can go out in the woods on my own property or your neighbor's property or your neighbor's front yard, and if you have a bad timber in your building, you can just replace it. Using these kind of tools that are very, very accessible. It can be this simple. And the other thing that I think is most important is that it utilizes labor and it trains people to do things and it gives people value and hope. And this is the Sweetwater Foundation in Chicago that we've done quite a bit of work for. Training people in south side of Chicago to do this kind of carpentry. There's just, when you involve people in community and you involve them in the buildings that are being built, they respect those buildings, they treat them differently. And community building is something that is in our DNA. It's in our human DNA to do that. What we're doing now is not natural. This is natural. This is normal. We get together and we put up buildings together. And we work together as a community. And we, over time, get to the level that we can do work like this. This is a twisted steeple. Very, I won't say common in France, but typical of some small French churches. Twisted steeples like this are at the high art of it. There's no architect or engineering involved in work like this. This is the carpenter's training. There might be architecture and engineer involved in the overall design or the loading of the building or things like that, but this part of it, this is the carpenter's work. And this happens to be one that we built near us and donated to our local volunteer fire department. This is an 8-sided pavilion with a boss pin. This is carpenter's work. This is the kind of work that we're talking about. We do work like this and people love the buildings. They respect the buildings, or we hope they do. And we can teach about it. So again, this is Sweetwater Foundation, and we did a whole series of classes there in the timber frame building that we built based on this. I think that's where I'm going to end. So this just happens to be a shot of the North Hayfield at our farm. How did I do on time? Did I? Lost track. 59 minutes. All right. Okay. Any questions? Okay. Yeah, Dick.
You said at one point there was 500,000 wood
Timber frames.
Timber frames in Illinois, and now there's less than 100,000.
Yeah.
Okay. I mean, I thought these buildings should last for 500 years.
Yeah, they should.
So what was the demise of 80% of them?
It's the foundations. And it's a couple other things. It's the wood shingles. So when they built...
I figured it was the roofs, but tell me about the foundations.
Well, the problem was just that, we live in this glaciated environment. So stones are sometimes hard to come by. So we don't get the buildings high enough above grade. We really need to be minimum 19 inches above grade with a wood building here. And too many buildings were what they've even called Illinois and Iowa barns ground barns because they're sitting at grade. So the bottoms rot out, the feet get wet, and in the 19th century, in this part of the world, everybody was putting wood shingles on things because it was cheap. And worse than that, in the early part of the 19th century, they were using pine, white pine, which has about a 10 to 15 year lifespan as a shingle. So it's the roofs and it's the.
So it's the really fact that the water table is this high here.
Yeah, and we have so much dirt. I mean, we just aren't, they weren't always doing as much foundation work
Other
as.
places doing them on better foundations.
Sure, if you go farther east, that's why I say it starts to be a little different in Indiana and Ohio, because soil changes a little bit and some other things change, and you get more buildings that are up on. It's not that folks didn't know, it's just that it was hard to do at the time, to gather that many stones together, to build a foundation that's 8 feet out of the ground. Cost, travel, distance, all these things. Our house from 1850 in Urbana has a limestone foundation, but it must have cost the guy an arm and a leg to put that in 1850, too.
Thanks.
Yeah. Yes, Ellie?
I have a comment.
Oh, yeah, what's your comment?
I want to get it on the camera, so if you wouldn't mind using a microphone, because we're recording.
We are? Oh. Hi. Okay, so my comment is, oh yeah, in the very beginning, you were talking about slash and burn.
Yes.
And I just learned about that in school.
Yes.
Yeah.
Yeah, some people don't realize that that's what was done here as well. And it was.
Comment or question?
Thank you. This is so interesting.
Thanks.
I have a million questions for you, but the one I'll ask right now is, when you first got interested in all of this, how did you find the resources to do those apprenticeships or learn about timber framing? Did you have a mentor? Was it a particular place you went?
Yeah, so in 1996, I started to travel a little bit, and I took my first workshop in North Carolina, actually. And then in around 1999, 2 or 3 years later, I started to get involved in an organization called the Timber Framers Guild. And I got very heavily involved in that organization, and I started to travel a lot to the East Coast, to Canada, Pacific Northwest, and work with other timber framers in shops and attend coursework and go to conferences. And that was about at that point, about a 10-year process. And in the middle of that, I started to travel a lot to Europe and go to European conferences and work on European projects as a carpenter. And so I kind of went from, this classic, fairly simple timber framing to some more advanced timber framing that's taught in the Northeast, to some more advanced timber framing that's taught in Europe. But it's about a 15-year, we never stopped learning, but the bulk of my training was probably over that 15-year period, because I was also running my business full-time and working and doing all these other things. There are a phenomenal amount of resources available in literature as well, which was a big part of that. And probably around 2002 or 3, I had a mentor for about a decade who was a very, very, very accomplished carpenter in New Hampshire. And he worked with us for 5 or 6 years in our company. So it's all of those things. It's travel, it's literature, it's what's written, it's conferences, it's all these things. It took all of that. Now there's a 4-year apprenticeship, there's a 4-year training program in Charleston, South Carolina for timber framing. It's the only one in the country. There are some small schools around, but there's just a vast amount of things you can do with wood in our trade. There's so many things to know. It's just never going to stop. But yeah, that's a long answer to your question.
Thank you.
Yeah.
I'll try to talk to you.
Okay. Yes, Ellie.
Where did you get all this stuff? Where did you learn everything?
Well, I learned it from a lot of different people. all kinds of different people, hundreds and hundreds and hundreds of people. For the last 30 years. Yeah.
Oh, thank you for this presentation. I am curious if you have projects that you're working on right now or coming up that you think are particularly exciting or have a lot of potential, especially related to sustainability.
Yeah, I think I'm not exactly sure what we're going to do next year yet, but we've been working on an 1840s mill outside of St. Louis that we've been trying to help a community save, that we will have to do a fair bit of restoration work on. We've got a couple of new construction projects coming in, but we haven't really locked in 2026 yet. It's kind of end of the year. It's getting to be end of the year, and sometimes we don't know the next year's projects until January or February of the upcoming, so it's not sure yet.
Lou, I was just wondering if you could speak about not necessarily the framing, but the like sheathing and siding and the technologies around that. I'm familiar with what's it called? Stress-skin paneling they use in timber framing, but I've always, if I remember correctly, that's like a giant slab of styrofoam, which has always struck me as not super sustainable. But I didn't, just was curious about that.
Yeah, so the industry, big part of the industry in the late 90s started to get built around the stress-skin panel industry. And stress-skin panels probably have about a 25 to 30 year lifespan. So if you put those on a building the last 300 or 400 years, you're going to look at changing those out fairly quickly. I think it's probably likely that some portions of the building will last 50 or 60 years, but it's not anything that we're going to see very long term. I started putting panels on buildings 25 years ago, and they started failing within 6 months of me installing them in some cases. So I do still do panels occasionally. I'm not fond of them. That's the styrofoam ones you're talking about. They also make a straw panel. They make a blue jean panel. They make a mineral wool panel. There's a sheep's wool panel. There's a lot of boutique panels out there in the stress skin industry as well. There's also the injected polystyrene, injected polyisocyanate panels that are made at Thermocore in Indiana. That's another type of panel. So that's what we'd call an exterior panelized system. And by and large, I'm not a real big fan of those systems. When we were just at this conference in Croatia, they were working on a bark panel, which I think sounds interesting, because they have a veneer industry and they're peeling these logs and they're going to make panels, insulating them with bark. Sounds great. And then there are nail-based panels, which are smaller than structural panels, which have some more application that allows you to use some different kinds of infill. Then there are built-up walls. And built-up walls mean that you build a timber frame and then you basically just stick build around it. And we can talk about the 8 dozen different ways that you could stick build around that building and use zip panels and woven walls and layers of insulation to stop thermal bridging. So that's the stick building end of it. And then the third category is infilling. And infilling is by far the most long-term. It's the most sustainable. It's the way that timber frames have been built for 4,000 years. And it's probably my preference. It's also the most expensive way to do it. And when you infill, you can infill with everything from straw clay to hemp to concrete to rammed earth to all of those things. So the 3 enclosure methods are a built-up wall system, a structural panel system, and an infill system. And a big part of our timber frame industry in this country was built on the structural panel industry. So that's one way to do it. The other way to do it, if you're not conditioning a space, of course, is just to build a timber frame and site it. But in general, in all those systems, we want to create a ventilated airspace between the siding and whatever the wall is. So my preference is built-up walls, and infilled walls, which allow us to use some things like some natural plasters and other kinds of plastering techniques on the inside that really blend well with timber frame buildings. That's how my house is done. My house is infilled. And for the insulation, it runs the gamut of just everything that's out there on the market, from torn up blue jeans to rammed earth to closed cell spray foam. which is how we're speccing a job right now where we're saving a carriage house, closed cell spray foam insulation. Does that sort of answer your question? Is that good? Yeah, I mean, it's a broad topic, but there's 3 main categories. Anybody else?
Me.
Yeah.
Okay, since I have the microphone, I'll take my chance. I really appreciate the questions MJ and Ellie and others asked about how did you get where you are. But I am the director of a program for students who are trying to figure out how to really approach sustainable solutions for the built environment. They're working in policy. Most of them are not going to pursue material, actual like making kinds of strategies. So what would you need from a supportive generation of people who are optimistic about our future? What would you call them to do without the expertise that you have to support the future of the work you're promoting?
Yeah, I think it goes back to the thing about valuing the work. I think that what we're trying to do is we're trying to educate people to value the work and value the buildings. And I think that's what they have to do. I think that we have to understand the inputs involved in structures so that we stop tearing down old buildings that don't need to be torn down, and that we start building new buildings that could be like those old buildings. And I think that's what, I don't think you have to know how to do the work any more than I have to know how to be a plumber. I can understand it, I can respect it, and I think that's what we need to do. I think we need to invest the time it takes to really understand the technologies that came before us and incorporate those with the technologies we're looking at today.
Ellie, I see you, but I'm
No,
okay.
I was just gonna ask, we're good. Okay.
I don't have.
It's not worth the mic. It seems like it's back to your value-added argument at the first. I mean, you're talking about can you frame it that way or not? That's all I was gonna ask. Is this a value-added argument? Because I think that can be very powerful.
I think it is. I mean, that's the way I saw it. I kept thinking about, and it all came back to Forestry Summer Camp in Missouri in 1992, where I went to sawmill for the first time in my life, and I saw these scarlet oak logs being sawn up into pallets, and a thing went off in my brain. I'm like, I can do better than that.
But it's not just the buildings, it's the appreciation.
Yeah.
I mean, the old building, I mean, you're talking about the aesthetics and the community and how people want to save them, but also they're good buildings.
Yeah. Yeah. So.
Or it's, I guess it's a range of things. I don't think I'm being that articulate.
No, I think you are. I mean, I think it's Vitruvius said it in the 1st century BC. It's Firmitas, Utilitas, Venustas. And we need all 3 of those things for a building to work. And all he did was borrow that stuff from the Greeks before him, 5 or 6 centuries. So that concept of utility, strength, and beauty, that's what buildings have to have. And that's a lot of value. And that's, I think, why people end up saving them. You get a whole generation of people that don't understand those 3 concepts and they just tear them down. But I think if we put that level of value into the buildings where there's a value to the utility, there's a value to the beauty, and there's a value to the strength of it. Strength is just duration and lifespan, of course.
But you're also talking about community building.
Yeah, I am talking about community building.
I'm trying to link that, I'm not sure.
Well, I mean, I've ran about 35 public raisings in the Midwest since 2000, and I have seen the power of what it does to a community when you go into a place and you build a farmer's market, or you build a bridge. We built the longest wooden bridge in North America in 2001, and it galvanized that community. It changed their tourism industry. We built a farmer's market in Vicksburg, Michigan, and it changed the entire downtown. That kind of community action. That's part of what we're missing, I think, here in this region. A lot of these public raisings I've done have been in other states, not so much Illinois. I've been saying for decades we need to bring that stuff here, but that kind of community building is a huge value add. I think people are investing in their buildings and so forth with their time.
I also think there's a pride element in it, but that's
Absolutely.
something that you and I can talk about later.
Yeah, absolutely.
I have 2 questions.
Okay.
My first question is, what is the first ever known timber frame that they ever made?
think it's the one from the peat bog in the Netherlands, at least in Europe. I'm not sure about Asia.
What is it though?
It is, well, like everything, they say it's a temple, but I don't think we really know. It's a very small building. It's only 8 feet by 8 feet or 10 feet by 10 feet.
And my second question is what's 4 feet?
A board foot is a unit of measure that's 1/12 of a cubic foot. And it's how we measure volume in this country.
It's 1 inch by 12 by 12.
There you go. 1 inch by 12 by 12.
Unfortunately, that wasn't on. Sorry about that. Just to make sure folks who need to go ahead and leave or feel that they can, I'm going to say maybe just another question, and then people could stick around to talk to you a little bit
Sure.
after and
Yeah.
see materials. Did you have a question?
Yeah, we have some things up front here too. Yes, Lee?
So the preservation side of things, as you know, I take down barns from people that can't afford the repairs, and I try to keep them intact and give them a new life somewhere. How can I convince these landowners to make the investments to keep these buildings in place? Is there an approach I can take? Because I'd rather see them where they are than to remove them.
Yeah, I think that's a campaign that that we have struggled with as well. And I think that one of the things I start off by thinking about is just because you can't fix it now doesn't mean somebody else can. So maybe we can talk to you about a way to mothball it. Maybe we can talk to you about a way to not just tarp the roof. You know, maybe it's putting on exposed fastener barn steel or something that will buy it a little bit more time. But I I face the same struggle, but I do try to say to folks, just mothball it till somebody else comes along that can. There's the oldest timber frame barn in Illinois that I've seen is the oldest American timber frame barn, not French. The French stuff goes back to 1680, but 1842, that one you guys went to in Kankakee.
Yeah.
I'm trying to figure out what to tell that guy. How do I tell him to keep it long enough that somebody else will do what I would call the right thing? I think it's education. These folks have to value those buildings, and I think we have to teach them the value of those buildings in one way or another without insulting them.
Yeah, because I feel bad removing some of them.
Yeah. Yeah, I agree.
And I would say as far as like, how do you get your students interested, the one thing I've noticed is just taking people and walk into an old barn, walk into a structure that's 100 years old and still beautiful.
Barns are very accessible buildings for that purpose, I think. Barns and bridges
would that
are
work
easy
for
to
you,
get
Seth?
into. Yeah.
Okay, yeah, one of my students just said that would work, so, okay, thank you. So I know that this was a small and intimate conversation, but just kind of like the mill talk yesterday, it seems like everyone who's here does something that's related to what you're doing and is building community around it. And so I'm so grateful, if it is intimate, that it's meaningful for all the people who are hanging out to probably ask you a lot more questions after I turn off the microphone.
Sure.
But it's just been an absolute privilege, and I hope this is the beginning of many more communications. And our students, 50 of our students raised a small barn today near the Siebel Center for Design for the FAA 230 class, and they brightened, they were curious, they were afraid, they became confident, like everything you're talking about making this a sensory community experience happened for us on a very small and quick scale. And so I'm very eager to see if we can do things that have a broader community impact and a greater invitation. It'll take me time to get more grants to be able to do that, but let's try to do that. So thank you so much, Nick and Rick and your children for coming and doing this. But please hang out to talk to Rick more. So thank you so much.
Thank you. I appreciate it. Thank you.